commands of Carol, the regular Carol. So one of the commands that she can use is the regular move command, which moves her one space the direction she's facing. Then there's the turn left command, which makes her turn left. Then there are two more commands that are very, very interesting. So one of them lets you put a ball. The other one lets you take a ball. And these are mostly used in the challenges and the regular things that are in this program or this website.
So the put ball is it puts the ball with
Yes.
Carol, and take ball removes the ball from Carol.
Yes.
Okay.
And then using that with while loops and for loops and things like that, you can make this, which I will explain after I show it to you.
Okay.
You can make this.
Oh wow.
So the way this works is at the start there's a clean world function. So
A what?
in the start function,
Yeah.
there's a clean world function that you can create using SuperCarol. SuperCarol is a different program from Carol because it has more commands that Carol knows, like turn right and turn around.
Uh-huh.
Because with regular Carol, you would have to put turn left 3 times, turn right.
Uh-huh.
But in SuperCarol, it has all of that already programmed into Carol.
Okay.
But in this program that I made, there's always at the start there was this clean world function that I made. Once the computer reads that, it goes to where the clean world function was written, and it reads the lines from that. While front is clear, which it is, clean row. This is calling the clean row function, and once the computer reads that, it'll read the line in the clean row function. First one is while front is clear, which it is. If no balls present, which there aren't, put a ball and move. Then it continuously reads those lines until the front isn't clear. So it keeps going through till Carol gets to a wall. The computer checks if the front is clear, which it isn't, and goes on to the next line. And then it calls the function around corner, goes to where the around corner function is, and starts reading the lines from there. It checks if Carol is facing east, which he is, and then since he's facing east, the computer reads and tells Carol to turn left. Then it goes on to the next line. If right is blocked, which it is, if front is clear, which it is, turn left and move. Then it goes on to the next line. Move and then turn right. Then it continues to read the things from this while loop until the front isn't clear, and then it just keeps going in each different direction, which is how this happens. So with this concept, you can I got this concept from one of the challenges, Super Cleanup Carol, where you start with this world, and your goal is to clean up all of the balls to make it look like this world. So originally, I had this code in this place. So instead of having it go through each row, it went just like that, like it did in the other code. But then I went through and edited it, so now it works like this. It starts reading the clean world function, goes to where the clean world function is, reads the lines from there. If front is clear, which it is, while front is clear, which it is, and this while loop makes it so that until the front isn't clear, it will continuously read the lines from the code after that. So while front is clear, call the clean row function, goes where the clean row function is. While front is clear, if ball is present, take ball. There aren't any balls present, so it moves. Still in the while loop, and the front is still clear. So it's gonna keep doing that until the front isn't clear. The front isn't clear, so it reads the next line. If ball is present, take ball. Ball is present, so it takes the ball. Reads the next line, which is the around corner function. It calls that, goes to here, reads that line. If facing east, turn left. Carol is facing east, so she turns left. So he turns left. Turns left, reads the next line. If right is blocked, if front is clear, move, turn left. Then it keeps doing that, turns left and cleans up all of the rows.
Oh, wow. So those two different commands gets it all right, gets it all
Yeah.
taken care of.
So, keeps going. Reads the next line, around corner. If facing east, she isn't facing east, else turn right. She turns right, reads the next line. If right is blocked, it isn't blocked, so it reads the next line. But the front isn't clear either. So it reads the next line, if front is clear, while front is clear, but the front isn't clear, so it stops. And then the next one was actually a concept from one of my instructors, Warren. So the goal here was to go through each hurdle and then continuously go around the edge. The way I solved this problem is I had a while loop which had the condition while no ball is present. There aren't any balls in this world, so this condition will never be true, and the while loop will always run. The computer reads that, goes on to the next line. While front is clear, move. The front is clear, keeps moving. The front isn't clear, so it reads the next line. Jump hurdle, goes to the jump hurdle function. Turn left, move. Turn right, move. Turn right, move. And it does this, and then turn left. Then it keeps reading all of those lines. So it continuously goes around the track, jumping through the hurdles. And then here's one of the mazes that one of my instructors had me do. These functions right here, they say while not facing north, turn left. So if he isn't facing north, he'll turn left. And until he's facing north, he'll keep turning left. So say if he's facing west, he'll keep turning left. Now he's facing south, now he's facing east. Then he starts facing north. So that's for all of the directions. And then I had these functions so that I could move faster instead of having to do everything else. Then I had all of these lines of code right here so that Carol would navigate through the maze. And so it runs like this. And then in the end, when he got to the ball, he took the ball. And this was one of the mazes. So then this is also one of the Carol challenges, which is the double the tennis balls that are in front of Carol. This was a tricky one because there aren't any like put two down or anything like that.
Mm-hmm.
So to do this, I had to make two functions. Function move to spot, the first one was the double balls function. So he would take the ball, he would move, and then he would put two balls so that for every one ball there would be two balls. Then he would turn around, move, and then turn around, and then keep taking the balls until all of the balls in that spot were gone. Then after that, there was this put balls back function, so that he would take the balls that were in this spot and move them back to that spot. Then there was a move to spot function, so that he would move from here to there and then turn around. And then so he moves to that spot with the move command, calls the double balls function, keeps doing this until all of the balls are gone, and then doubles them up. Then it calls a move function, turn around, calls a put balls back function, while ball's present, take ball, move. So he keeps doing this until the balls are in their original spot, which will require for this challenge to be completed. So he does all of this, and then move back to spot, move, turn around. And now he is in the original spot that he was in on the world on what he was supposed to look like, which is shown in the world on the left. And
hold on just a minute before you, I just want to explain something here. So there, you can see here, this is